Hello and welcome to the Critical Power channel here at DCD. I'm Alex Dickens, Head of Broadcasting, and this month we're delighted to be bringing you a tech showcase which will explore the transformative impact of grid interactive technologies in a market of power capacity constraints, sustainability targets and renewable agendas. Now, bringing this topic to life, I'm excited to introduce Michael Mahon, Commercial Solutions Lead at Enel X. In his capacity, Michael drives the development and strategy of the demand response portfolio as part of the organisation's wider offering, which specialises in advanced energy solutions from storage to smart grids. Michael, great to have you here. I will hand over to you to take it away.
Brilliant. Thank you. Thank you very much for the introduction. Okay, grid interactive UPS technology. So before I dive into it, I just maybe want to set the stage a little bit. So globally, there's obviously this drive towards achieving more renewable energy on the grid, which is fantastic, but it poses a number of challenges. And one of those is that renewable sources like wind and solar can affect grid stability. So in addition to this, we also have energy consumption is also increasing, and data centers are partially contributing to this. And as a result, they've been criticized for compromising these efforts. So, how do we achieve higher levels of renewable penetration without breaking the electrical grid? And can data centers be part of the solution rather than the problem? Well, yes, absolutely. Data centers are an integral part of the grid, and we see them as assets rather than burdens. And grid interactive UPS technology is one way to realize this. So, I'm not selling UPS technology. You really should already have these on site if you're a data center. This is not going to solve all your energy problems. It's not going to eliminate scope 2 emissions or get you a 50 megawatt grid connection. But it can help with some of the goals that data centers and grid operators are trying to achieve. So, grid interactive active UPS technology. So what is it? Well, it's a form of frequency response using UPS equipment. So what is grid frequency? Well, for the purposes of this presentation, it's a real-time changing variable that indicates the balance between energy supplied by the grid and energy demanded by consumers. In Europe, this is maintained at 50 hertz, and it's absolutely critical that it stays within 1% of this. Deviation outside of that value, and you're looking at potential rolling blackouts on the grid. So not a place you want to be. So maintaining grid frequency is this constant balancing act between supply and demand. So I don't have much time to go into it, but historically, this has been easier to maintain when the power supply was from thermal generation, which had lots of spinning inertia. Now, as we move towards a grid with more renewable sources, it's harder to maintain that frequency. So wind and solar can't respond in the same way to sudden drops in supply. So instead, that balancing mechanism comes from the demand side. So essentially, frequency response is a rapid, controlled drop in demand in response to a sudden drop in supply. The most sophisticated form of this is dynamic frequency response, which is suitable for UPS and batteries. So everything I talk about here is actually applicable to batteries. I just talk about UPS equipment because everybody has it on site. So that's frequency response. So how does it work? So we install equipment on site. So this is a sample layout. So there's our equipment, the white box. It's called a ZDR. It was developed in conjunction with one of our partners. So it's mounted in a site in a data center somewhere. It takes a power reading and it takes a frequency reading. Then relays those readings normally through a 5G SIM to a remote terminal unit and up onto our platform. We then relay that information to a grid operator. In Ireland, that's EirGrid, for example. So I say information, but again, it's just a power reading. And this is just to say to that grid operator that data center A is standing by with 5 megawatts to support in grid services. So you also have the UPS load. The UPS you can see there. So that's standing by to support critical load. Then there's a CAN bus connection between our equipment and the UPS. So that's the layout. So what actually happens during a frequency event? So the equipment is installed and it's standing by. So let's imagine something really bad happens on the grid. A generator drops out, or worse yet, an interconnector. So suddenly you have 2, 3, 400 megawatts of load just dropping off the grid. Subsequently, you get a drop in frequency. Our equipment registers this drop in frequency if it crosses a certain threshold. Once it does so, it will send a request to the UPS to take up a little bit of that critical IT load. So we're not tripping anything. We're not sending a command. We're just asking the UPS saying, if you're happy with all conditions, are you able to take up some load? This happens not just at one facility, but at multiple locations all around the grid in any given country. So the grid then sort of sees a drop in the demand side. And as a result, the frequency is normally restored. And this is normally within a few seconds. Now, there are other activities that take place to also restore frequency, but essentially the net result is the frequency restored in a few seconds. At the same time that this happens, notifications are also sent out to personnel. So emails and texts are sent to people on site so they know this has occurred. And then when the event is over, they're also sent notifications so that they know the event is over. So that's an overview of the process. So what's the impact on your UPS? So, well, the system has been designed in such a way that has minimal impact on the equipment. In fact, we think overall it enhances the resiliency of your support system. So for a start, we would suggest that you only use a fraction of a UPS and always maintain a reserve capacity that covers your requirements. For example, you could have a 1 megawatt UPS supporting 500 kilowatt of IT load. So you could offer up some of that excess to support in frequency response. So the longest that the equipment will participate is for up to 5 minutes, for example, in the Irish market. In practice, events are normally over in a few seconds. So worst case scenario is a frequency event followed by a power cut. In such an instance, you are still covered and likely running on generators. They're also not that frequent, normally 2 to 3 a month. Last year, we had 24 in total. There's also the option to opt out after an event, and this can be built into the process. So if your UPS is requested to participate, there can be a freeze-out period of 2 to 4 hours, for example, where it is not going to receive another request. And this is to stop a situation where things are very bad on the grid and the UPS is getting multiple requests, and this could discharge the piece of hardware. And it also gives your UPS time to recharge if needed. On top of that, we also have an online platform where you can log in and opt out ahead of time. So if next week was very busy, or if it was a commercially sensitive week, if it was Cyber Monday or Black Friday or something like that, and you did not want any disruption to your operations, you can log on to our platform and bid out ahead of time. You can also do this if you're planning any maintenance. So you have the ability to control when you want to participate in this market. There's also locally disarm switches, so there are multiple layers of protection. And the only downside to using these options is that you don't get paid for that period. Which brings me to my next point, which is, and I don't want to linger on this too long, you are actually getting paid for this service. So all in all, you can see that it's only a few minutes for the whole year that you're actually, the UPS is participating, but it actually has a huge impact. So we're not looking for guinea pigs. This is something that we are doing with multiple data centers, multiple data center customers. This is a case study that we did with Digital Realty. So they were looking for ways to support the grid and be a good grid citizen. So in Ireland, data centers have been unfairly targeted as contributing to some of the issues that the grid is having. And they wanted to help change that narrative. So they have 6 megawatts of UPS technology installed, and they were able to utilize this to provide support to the grid, allow more renewable energy on the grid, and provide a consistent revenue stream for their efforts. They also picked up a couple of awards along the way. So to summarize, UPS, a grid interactive UPS, is a way to use existing assets that you have on site to allow more renewable energy to come onto the grid, to provide more support to the grid stability. Do you remember, a more stable grid is less likely to cause problems for your operations. You're also providing a consistent revenue stream. So this service essentially acts like an energy bill in reverse. You're getting paid for the kilowatt hours that you make available. It's also a way to test the resiliency of your equipment on site. So yes, you might have UPS equipment and backup UPS equipment, but how often is it used, and do you know it can perform when it needs to? It's also, pardon me, sorry. It's also a signal of intent to grid operators. You're telling them you want to do what you can to support. You want to be part of the solution, not of the problem, and you're doing everything you can within the means you have. And then finally, as you saw on the previous slide, it is a marketing opportunity. You're doing lots of good things. It's worth shouting about. So I'll leave it there. Thank you very much.
Brilliant. Thank you so much, Michael. I've got a few quick questions for you. I guess firstly, you talk about the kind of nature and duration of UPS demand response. Perhaps you could elaborate a little bit here and give a couple of examples.
Yeah, so I mean, with this particular service, and I'll use Ireland as an example because I'm most familiar with it, it's not a case that the UPS takes all of that load all of a sudden. So if you're offering up 300 kilowatts, it's not a case that all will be dispatched instantly. There's actually a smooth sort of ramping rate. So, and it's also in response to the magnitude and the duration of the frequency event. So again, if the total frequency event were to last for 20 seconds, it's not saying that the total amount of available charge of the battery is used for that period. It's just depending on the duration and size of that frequency dip.
Brilliant, thank you. And we talk a lot about adaptive design when it comes to power, and kind of flexibility is a bit of a buzzword at the moment, but it is absolutely integral. How are your solutions at Enel X helping enable flexibility when it comes to energy, particularly in this quite capacity constrained era?
Yeah, I think adaptive is the key word there. I mean, we're sort of not there day one on the construction of a new facility or a data center. So it's about working around the assets that a site has and the design that it has. So it's about working with what they have in place. It's also about understanding, the needs of the data center and the needs of the market, and also the markets that they operate in and the constraints they're in. Like we operate, nearly 100 programs in different countries around the world. So it's about sort of pulling those different components together and seeing if we can provide a service that's suitable for that customer.
Mm-hmm. And we talk a lot about reliability, uptime, and ensuring service. But another big part of this is obviously sustainability. When it comes to kind of CO2 savings, how can this service, help drive carbon reduction goals? I see one of the lines in the case study mentioned this.
Yeah, so it's not the CO2 savings. They're not coming from the fact that the UPS is taking load for a few minutes for the whole year. It's without having this service in place, we're not actually going to be able to get these high levels of renewable energy on the grid at any given instant. So without this level of flexibility, we'd be stuck on maybe only allowing 20% of our power to come from renewable sources, which but right now it's up to like 65% in Ireland, for example, and that's because of flex services that we have.
Mm-hmm. Mm-hmm. Brilliant. And my final question, which I'm sure you've got some interesting perspectives on, given the relationships with the grid in Ireland. But we talk again a lot about energy partnerships, and in a modern context, how does this work, and how has Enel X established reliable partnerships with different players within the power supply chain?
Yeah, so partnerships are critical to us because we're not selling like a once-off solution, and we need the cooperation and collaboration of our customers. If we were just selling power to our customers, that'd be in one direction. That's just a one-way transaction. Sorry, I hope I explained that correctly. But we rely on them to participate in these services, and they rely on us, to ensure that they have everything they need to participate in these services and in these markets. So it is that sort of partnership. And then on top of that, we also work with grid operators. We work with hardware providers like UPS providers and battery providers. So it's about having those partnerships as well in place. So these are all key. So we're all about just sort of having relationships between different stakeholders in the industry, and that's how we sort of build our business.
Well, Michael, I've got to say that was a fantastic presentation, and thank you very much for tackling those questions. Unfortunately, that is all we have time for on this occasion, but thank you very much for coming in to share your perspectives, and thank you to our audience for tuning in. If you did miss anything, this episode will be available on demand shortly, and you can also find some helpful resources on the bottom right-hand side of your screen if you'd like to read about Enel X and what they're up to in more detail. Michael and the team, of course, would love to hear from you, so please also get in touch with them. That's all we have time for this month on the Critical Power channel, but we'll be back at the same time next month with more. Thank you.